Hi, have you ever seen that guy before? Probably not as horribly drawn, but that's Sir Isaac Newton. And one day in the summer of 1666, an apple fell on his head, and he couldn't be satisfied with thinking that maybe the apple moved because it wanted to move. So he devised 3 laws that we use in physics to describe motion. Law 1 states that a body at rest will remain at rest, and a body at motion will remain in motion unless acted upon by an outside force. It's important to understand that an outside force could be something like air resistance or gravity. This experiment demonstrates Newton's first law, also known as the law of inertia. I have a cup with a card and a coin on top of it. When I move the card slowly, the coin moves with it because the friction between the coin and the card applies a force, causing the coin to accelerate with the card. But when I move the card quickly, there isn't enough time for the friction to move the coin, so it stays in place due to inertia and simply falls straight down into the glass. This happens because the object resists change in motion unless acted upon by an external force. Newton's second law states that the force acting on an object is equal to the mass of that object times its acceleration. This can be written as this equation or rearranged into other equations like this. To show the difference in acceleration, I have 2 toy trucks, both tied to a string, both tied to a shoe that will be an equal pulling force when I let go. When the trucks are the same mass, they accelerate at the same rate, but if I add a weight to one of them, you'll see that the lighter truck accelerates at a greater rate. To help visualize this, I've wrote it down in this equation. The pulling force of the shoes is equal, so the force is the same on both sides. Since I added weight to the second truck, I'll draw the mass bigger on this side. When we divide the force by the mass, we'll find that the acceleration of truck number 1 was greater. Newton's third law is probably the most well-heard. For every action, there's an equal but opposite reaction. But that's actually a little bit too vague, and it's forgetting a word. Like, what kind of action? Like, if I have a really hard time coming up with concepts for this video, am I going to have a really hard time doing it last minute? Probably. But the word it's missing is force. Updated here, we see that Newton's third law is for every action force, there's an equal but opposite reaction force. To help put action and reaction forces into perspective, I have this inflated balloon taped to a straw on a string. When I let go of the balloon, the air forcing itself out of the balloon will be the action force, while the reaction force is the balloon pushing itself along the string. These forces are equal in magnitude but opposite in direction. It's important to remember that no matter at what point the balloon is going across the string, the force of the wind pushing out of the balloon and the force of the balloon going across the string will always be equal but opposite. I hope that now you have a confident understanding of Sir Isaac Newton and his 3 laws of motion.